excited that you guys are tuning in for our review video. I am reviewing lessons 4, 5, and 6 in Module 3. I know we had a wacky week with me being away, and I know that there's a little bit of confusion, but our learning target for this video is to clear up any confusion that we might be experiencing. Here's the truth, you guys. You know how to do this. We did a lot of this as review from 4th grade. I think you just need to be reminded that you know what you're doing. You guys are a clever bunch of kids. I understand the frustration, but let's just take about 15 minutes here and refresh ourselves and review and reboot. I'm going to set up 3 separate problems for you from lessons 4, 5, and 6. And then you are going to bring in the answers for these problems on a sheet of paper on Monday for your homework. So let's do this. You guys are going to do a great job. Just to review our schedule for next week, Monday we're going to be doing lesson 7, which is multi-step word problems. Tuesday we'll have our mid-module celebration of learning. That is going to cover all of the great things that we've done in lessons 1 through 7 so far in Module 3. And then Wednesday we'll just continue doing our thing. It's going to be a great week. Excited for things to get back to normal. Appreciate all of your well wishes and all the love that you've sent my family's way. And let's do this. L4. This is a problem, a review problem from lesson 4. The only thing that we're doing in lesson 4 is we're adding fractions. The sum, the answer to the addition problem, is going to be greater than 1 whole, meaning the answers are going to be improper fractions. It is very, very important that we stay consistent with our modeling, meaning our first number, we are going to use vertical lines in our model. Our second number, this 3/5, we're going to use horizontal lines when we model. It is very important that we stay consistent with this. If it helps you to set up this note before you're modeling, go for it. So very simply, I'm going to go quickly because we did this a while ago and this should be just kind of a refresher. So let's set up 2 rectangles. I'll work on making them very, hopefully nice and neat and straight. They're not very straight, so we'll just use our imagination, pretend that they are. I would like to try our very best to make sure that these rectangles are the same size, because each of these rectangles is representing 1 whole. It's important that they look the same size. So 1/2, we're going to use vertical lines to divide this rectangle into 2 equal parts. We're going to shade 1 of our halves because the numerator is 1. So we have 1/2 here. Here, we're going to show 3/5. We're going to use horizontal lines for the modeling of this rectangle. We're going to slice this rectangle into 1, 2, 3, 4, 5 equal pieces using horizontal lines. Now we're going to shade in 3 of our 5ths. Okie dokie. So now we have 1/2 and we have 3/5. Now we need to lay 5ths on top of our halves, and we're going to lay halves on top of our 5ths. I'm going to change color so that is easy for us to see. Okay, so 3/5 we're going to use our horizontal line. So I'm going to draw I'm going to draw 4 lines on top of our halves so that now we've laid 5ths on top of halves, and we've sliced this rectangle into 1, 2, 3, 4, 5 equal pieces. Now we're going to take halves and we're going to splat. We're going to lay our halves on top of our fifths. Notice that I'm still using my vertical lines for halves and I'm still using my horizontal lines for fifths. Now, by the power and the magic of mathematics, we've shown that 1/2 is equal to 1, 2, 3, 4, 5 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow! We've just shown that 1/2 is also equal to 5/10. Let's see what let me put my equal sign in here. Let's see what we've learned over here about our 3/5. We've now learned that 3/5 is also equal to 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow. So we've now learned that 3/5 is equal to 6/10. All we need to do now is rewrite our expression. So we have 5/10, because we learned 1/2 is equal to 5/10, plus 3/5 is equal to 6/10. Now you guys can go ahead and use your brain power and solve this. The reason why we can solve this now is because we have common denominators. We cannot add two fractions that do not have common denominators. That's just not going to work. So for your first problem, for your homework assignment, I need you to label L4. I need you to write this expression. I need you to write this expression and I need you to solve it. Hopefully you won't use too much brain power solving it. Hey kiddos, here we are. We're getting into a review problem for lesson 5 next. So what I need you to do for this problem is please label it, oh, that's different. Please label it L5. So in L5, we are still working with fractions. The only difference now is that we are subtracting fraction. We're subtracting one fraction to another. So we are still going to be using our rectangular modeling method. We're still going to be abiding by the first number we're going to model with vertical lines. Second number we're going to model with horizontal lines. Please stay consistent with this. Otherwise, life is going to be really complicated. Listen to me. I know what I'm talking about. Okay, let's look at C again. I'm going very quickly. If this is too quick for you, pause, rewind, think about it, process. Make sure that you're taking in this information at your own speed, depending on where you are in your understanding. So we are starting with 5/6. We're taking away 1/4. So we're going to model this. Let's see what it looks like. So we're starting with 5/6. Again, we want to make sure that our two rectangles are pretty large so that we are able to count all of the tiny squares that end up filling these rectangles. Okay. Yes, this rectangle is larger than this one. Let's pretend they're the same size. So 5/6. We're going to use vertical lines. I'm actually going to change colors here. We're going to use vertical lines to partition our first rectangle into 6 equal slices. Okay, so we have 1, 2, 3, 4, 5, 6. We're going to shade 5 of them. There we go. We're going to shade 5 of them. So we have 1/6. We have 2/6. 3, 4, and 5. Okay. So here we have 5/6. Okay, now we're going to show 1/4 in our second rectangle. Our second model, we need to make sure that we're partitioning that rectangle in horizontal lines. Try to make those lines straight. Don't be like me and make them wavy. I'm trying my best. My word. So now we have 1, 2, 3, 4. This rectangle is sliced into 4 equal pieces. Now what needs to happen, kiddos, is we're going to shade. Who can tell me how many fourths we're going to shade? Chloe? Thank you, Chloe. We're going to shade 1 of our fourths. This is my shading music. Okay, so now what needs to happen is we're going to label our fourth. So this is 1 fourth. Now we're going to throw fourths on top of our sixths, and we're going to throw sixths on top of our fourths. Can I move that? Oh, sweet. So now we're going to draw horizontal lines. I've lost my pen for some. Now we're going to draw horizontal lines on top of our fourths, and we're going to cut our first rectangle into 4 equal slices. And now we're going to take our sixths and we're going to use vertical lines to partition our second rectangle into 6 equal slices using vertical lines. Okay. So now we have 1, 2, 3, 4, 5, 6. Beautiful. So now what should become immediately apparent is that 5/6 is equal to some new fancy fraction. Let's see which fraction that is. 5/6 is equal now to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 out of, let's see, well, this rectangle is 1, 2, 3, 4 units high, and it's 1, 2, 3, 4, 5, 6 units wide. 4 times 6 is 24. Okay, let's see what 1/4 is equal to now. It's equal to 1, 2, 3, 4, 5, 6 over, we know this rectangle is 6 wide and it's 4 high, so we have 6 24ths. Beautiful. Now what needs to happen is now we're going to rewrite our expression. This original expression, these fractions do not have common denominators, which means, as Kylie I think is thinking right now, we cannot subtract them until their denominators are friendly. Their denominators now are in the same language. They both have denominators of 24. So let's go ahead and rewrite the expression. We have 20 24ths. Again, why is it 20 24ths are equal to 5/6 as we've shown in our modeling above, minus 6 24ths. 6 24ths again are equal to 1/4. So you guys are going to go ahead and do the subtraction here. I need you to, for your second problem, label it L5, and I need you not only to write this expression, but you must solve this expression, simplify the expression if you're able to, and then I'm going to show you up here how to model the subtraction of these two numbers. So we're starting off with 5/6 or 20 24ths, and then we're taking away 1/4 or 6 24ths. And the modeling of this is very simple. All we need to do is take away 6 24ths. We're going to model that taking away with x's. Ready? We're going to take away how many 24ths, Kyle? 6. Thank you, sir. We're going to take away 6 24ths from this 20 24ths. And here's how we're very simply going to do it. We're just going to use x's. So that's 1, 2, 3, 4, 5, 6. We've taken away 6 24ths from our 20 24ths, and now your mission is to show me in your model and in your written expression how many, I'm going to outline what we have left in red. You need to show me in your model and in your expression right here how many 24ths we're left with. Cool. So that's lesson 5, you guys. It's not as bad as I think you were originally thinking. So we're going to continue into lesson 6, and here goes nothing. So here we are in lesson 6. This is the final piece that you're going to need from your for your homework. So I want this this one to be labeled this problem to be labeled L6. In lesson 6, we're still subtracting fractions, but we're starting with a mixed number or an improper fraction, meaning this number is larger than 1. This is 1 whole plus some. And what we're going to be doing, instead of modeling these separately, we're actually going to lay this model on top of this model. Because in subtraction, this is actually the more logical way to do this, because in subtraction, we're not adding 3/4, we're taking away 3/4. So we're actually going to be modeling, showing, proving on top of the 1 2/5 that we're removing 3/4. So let's look at this. 1 2/5 is, Kendi, 1 2/5, is it greater than, less than, or equal to 1 whole? Thank you, Kendi. 1 2/5 is greater than 1 whole because 1 2/5 is 1 whole. We're going to divide this 1 whole into 5 equal parts. And we're going to shade in all of the equal parts because it's 1 whole. Let me choose another color here. How about gray? We're going to shade in, I need that to be much, much thicker. We're going to shade in 5/5 because 1 whole is equal to 5/5. And then we need to also divide this second rectangle into 5 equal pieces using vertical lines. 1, 2, 3, 4. We'll pretend that those are equal. And in the second rectangle, we're going to shade in, oops, just 2 of our fifths. Ooh, that's very efficient. So now we have 1 2/5 shown. Now what we're going to do, you guys, is we're actually going to lay our fourths on top of our fifths. We're going to lay our fourths on top of our fifths so that we can take away three of our fourths. Okay, so here goes nothing. So we're now going to use horizontal lines to lay fourths on top of our fifths. Oh, I think I made that one too chunky, but that's okay. Okay. So now we've laid, do you guys see how we've laid our fourths on top of our fifths? And we're also going to do that over here because we're starting with 1 2/5. So we need to make sure that we're treating this entire model the same because this is one model for 1 2/5. Okay, so now let's look at 3/4. 1, 2, 3/4. Do you guys see those top 3 rows represent our 3/4? 1, 2, 3/4. What we're going to do, you guys, is take away 3/4. We're going to model that taking away with x's. So we're going to take away, we're going to x out 1/4, 2/4, and 3/4. Okay. So now we've just shown 1 2/5. We started with that in the gray, and then we've taken away 3/4 in our purple. Now I'll use this blue to now write our expressions. So 1, oh, I did not want to do that. 1 2/5 is equal to what? 1 2/5 is equal to, well, let's see, this rectangle is 5 wide and 4 high. That's 5 times 4 is 20. 20 20ths plus, sorry, that got, yeah. 20/20 plus, how many 20ths do we have here? Well, again, this rectangle is 5 wide and 4 high, so this rectangle is partitioned into 5 squares. We have 1, 2, 3, 4, 5, 6, 7, 8 of those squares shaded in gray. So 1 2/5 is equal to 20/20 plus 8/20. Okay, and then 3/4, remember that purple, this 1, 2, 3 rows. 3/4 is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's the purple. Out of, we already know this rectangle is divided into 20 squares. Okay, so 1 2/5 are equal to 20/20 plus 8/20. 3/4 is equal to 15/20. So now we need to rewrite our expression. Well, actually, let's go ahead and simplify this. 20/20 plus 8/20, Anna, thank you, is equal to 28/20. Now we can rewrite our expression and just do our very simple subtraction. So what we end up with is 28/20, thank you, Kate, minus 15/20, thank you, Mason. What you guys need to do for L6 is you need to show me this amazing modeling. You need to write this expression. Not only write this expression, but solve this expression. Wonderful, wonderful job, you guys. Cannot wait to continue reviewing with you on Monday.